All right, we're going to look at graphing our functions that we're looking at, the different functions we're looking at, the constant, linear, quadratic, and cubic functions we've been looking at. We'll look at graphing them using the TI-83. I'm using the emulator on my Android. It's the same as your TI-83 Plus. All the buttons are the same, all the functions are the same, all the workings are the same. Where you would start normally when you go into it is when you turn on your TI-83, you'll have a screen like this. The first place you go when you're going to graph a function is you go to the y equals. When you're at the y equals, you'll see all these y equals, y1 equals, y2 equals, y3 equals, and so on. And also at the top, you'll see plot 1, plot 2, plot 3. Right now, we're going to turn those plots off. So if they're on, they'll look like that. You might have one on because of the last time somebody used the calculator, but you should go to any of the ones that are highlighted in black, hit enter to turn it off. If you don't turn it off, there's a chance you're going to get an error message later on. If you get an error message, something like invalid dim, I think that's what it actually says, that chances are your plots are on. One of your plots are on, so go back and turn them off if you're getting that error message as we go forward. So once you're here, so you just hit the y equals button to get here. Once you're here, you simply put in the equation that you're going to look at. So one of the equations just straight out of the textbook, you're going to be doing this question a little later. 3x minus 1. So you just put it in there. Once you have it put in, you can hit enter to go on to the next one. It's not overly important. As long as it's written in, that's fine. Then you hit graph. As you can see, when you hit graph, you go to this graph. You go to the graph screen. It shows you a graph of your function. And there's a particular domain and range that you have. So range, your y values, domain, your x values. You can change these by going to the window. Hit window. And you'll probably see that your window's set up as -10 to +10 for both of them. The minimum value, -10, maximum value, +10. That's a pretty standard one. We're going to look at changing it around a little bit later. But one thing you may have ran into is as soon as you hit graph, you got an error, and even your plots were fine. When you went to your window, the numbers would have been all messed up. If you hit graph and you got an error, go to zoom, and then you see number 6 is zoom standard. So just hit 6 on your calculator and it'll reset everything to being 10 to -10. It's a good place to start. Most of what we do is going to be visible, at least in there. We're going to adjust it a bit. So that's the basics of of graphing. You hit the y equals, you enter your equation, you hit graph. Then you're going to have to set your window up. When you graph, the easiest ones to graph, of course, the easiest ones to look at, of course, are going to be our constant terms. I know if you notice there, anytime if you have other things listed here, just go to them, hit clear, it'll clear the whole line. So when we look at a constant term, say 5, and we graph it, we'll see we get a nice horizontal line there at 5, at y equals 5. So it gives us the normal things that we can see. We can see this is a constant. It has one y-intercept, no x-intercepts. And that's pretty much all we're going to see with a constant. When we go on to doing something like a linear graph, we're going to have to get a few more values that we're going to want to get out of it. So I'll put back in that line that we had before, 3x, that x, t, theta, and n. That is where we get our variable from. I've been at some people before have asked me what that button's for. Now we know. Now you know that's what it's for. So 3x minus 1. And then I'll graph it. And you can see right here in the middle, we're all muddled up. Everything's right around here, but they aren't exactly lined up. So what I want to do is I actually want to zoom in a bit. So I can just hit the zoom and then choose number 2 to zoom in. And it says where do you want to zoom in around. I'm going to zoom right in around 0, 0 there. I can move the cursor around with these buttons here to choose a different place. That's going to be where it centers the zoom around, so I'll just, there, that'll be fine. Not overly worried. Now I see it zoomed in right around there. I can see a lot more of what's happening now. I can see that I have, not at the origin, I have a y-intercept and an x-intercept. Okay? And we can actually hit trace, and then it takes the cursor and puts it on the line. And now if I move my cursor along the line, it tells me only values that are on the line. So I can see here, I get this value of, I'm almost at 0 with my x, -2 times 10 to the -9, and my y value is -1. So my y-intercept is probably going to be right around -1. I can get these from tracing, so I can go up to where y almost equals 0. That's probably somewhere in there, somewhere between those two. So I'm not going to get a perfect answer here. Yeah, I'm not going to get a perfect answer here, but I'm going to get pretty close. X is going to be around 3.2. If I want a better value, I actually have I have another function. So second function second function trace gives you this calculate menu, calc. And you can calculate a value, so you can look at, you can input a value for x. So I could say if x is 9, but it's going to be out of my screen. Whatever. If x is 9, there it shows invalid dimensions, because I went outside the range. So I go second function, calc again, go back to where I was. Go value, then I have to choose a value that's inside my window. That's where I'd want to reset my window to being bigger than it is. X's here go from about -2 to +4, so I'll say 1. If x is 1, then hit enter. If x is 1, I get my y being 2. Okay? So that's going to work. You can use that for any of them. Second function calc, go back to the main menu. I can calculate the 0. So the 0 is our solution. So when you go to calculating 0, it tells you this weird thing. It says left bound. Well, all that means is it wants you to move the cursor so that it is on the left side of where your 0 is. Hit enter. Then you move your cursor to where on the right side, because it asks for the right bound. Hit enter. So now it says between here and here, it's going to look for 0. You're going to hit enter then. And now it tells you my 0 is 0.33333, which is a third. So that's how the 0 function works. The other one that you might want to look at, it's pretty straightforward with a line, but you can calculate slope. I find this rather silly because you already have the equation. So my slope here is 3x, but I can also go to the second function calculate menu. I can go choose 6 for dy dx, which is change in y and change in x. Another way to say rise and run, which is slope. And then you just choose a point that you want to find the slope from. Since the slope's the same at any point on the line, you just choose anywhere. Hit it, and it says your dy dx is 3. Your slope is 3 at that particular point, which we already knew from our function, but sometimes it's useful in other functions that aren't straight lines, functions that have curves. You can find the slope at any one point in time. So that's a linear function. The quadratic function, we end up doing the exact same things with it, but there's a couple other things we want to look at. So I'll take a quadratic function from your book. -2x squared, oops, yeah, 2x squared minus 5x plus 3. All right, if you notice when I had the negative here in front, I had to use my negative, not the subtraction symbol. If you use the subtraction symbol, you'll get an error. When you go to graph it, it's not valid. So I put that in and I hit graph. And when I do graph, you'll see I'm really not getting much out of my graph right now. That's because my window's wrong. So I'm going to go zoom. And I'm going to pick standard again. So now I'll get from -10 to +10. And there we go. Now we have a nice curve. I can do the same things I did before with this. I can trace it if I want. I can also calculate a value, but I'm going to look at calculating a 0. And here there's 2 zeros. So when I go to calculating 0, which is number 2, it's still to ask me for left bound first. So I can calculate this 0 by going left of it, or I can stay where I am now because I'm left of this 0. So I'll hit enter there, and I'll go over to the other side. Oh. And I have a right bound, and I hit enter. And I calculate my 0. My 0 is x is 0.5, so a half when y is 0. So my answer, or my 0, is 0.5. X equals 0.5. But that's only one of my solutions. I also have to look at the other solution. No, come on, let me move over there. There we go. I'm probably going to hit trace and it's going to send me, yeah, right where I was before. All that wasted time. So I'm just going to set my cursor up left to start with before I even go to the calculate menu, because I know that it's going to ask me to be left of my 0. So once again, go to the calculate menu, choose 0, left bound, enter, right bound, enter. So left of where the 0, where it intersects the x-axis, right of where it intersects the x-axis, hit enter, and it tells me my other 0. Here we see that y isn't exactly 0. It's because it's not really using a mathematical calculation, it's more like using a trace calculation. So sometimes you don't get it, but it's really, really close to 0. It's 0.00000, 11 zeros, then 1. So it's really close to 0, and x is -3. We can just say that our 0, this other 0, is -3. Okay? So that's calculating the zeros with this, just the same as calculating with the linear function, but now we have 2 separate zeros. And we can also calculate, there's another useful one here, we can calculate a minimum or a maximum. And this is very important with our quadratic functions when we're trying to identify which one matches a graph, which is one of the things we'll be asked to do. Well, if we go to my graph, we'll see that I have a maximum value. Because it opens down, I have a maximum value, so I go second function calculate. Then I go maximum, choose 4. Then once again, we do the left bound, right bound thing. Well, my maximum, I'm left of it here, enter. And I am right of it here. Okay, hit enter again. Takes a little bit longer. It tells me my maximum point is x is about 1.25. Negative 1.25, and y is 6.125. We can turn those back into fractions. So x is -5/4 and y is positive 6 1/8. So we can leave it as decimals though, because that's what it's given us in our calculator. So we can calculate the zeros, the maximum and the minimum. It is the exact same for a cubic function. So I'll just clear that off, grab a cubic function. So 2x to the 2. So that's how you do cubic. You go to the power of 3. Sorry, to the power of 3, not to the power of 2. Plus 4x minus 3. Sorry, that's x squared. Minus 3x plus 1. So it went on to the next line. Doesn't matter. The calculator will deal fine with that. So we'll hit graph again. And we get our cubic. We can calculate a 0 here. All right? Right here we have a 0. Here we have a maximum, and here we have a minimum. So we can calculate all three values just like we did with the quadratic function by using the calculate menu. Our 0 will calculate the 0, the solution, the minimum, and the maximum calculations. Those are the most important ones for us to calculate. It helps us to identify, because that's really what we're looking at today, matching graphs. Pretty basic stuff. So if we start going, and I'm going to actually do one of the questions. If you want to follow in your textbook on page 388, I'm going to try and match the px on 388 px. So if you look at px, the function p of x, it equals x cubed minus 2x squared minus x minus 2. So I enter that in, and I can graph it. And I can get a look at what it looks like here. What I'm asked to do is I'm asked to match it to one of the graphs that are below it from numbers 1 to 6. If you look at graphs from 1 to 6, there are only two of them. 4 and 6 that even come close to the shape of what we have here. We can if you look really quickly, you can see that 4 on page 388 gives us the correct shape where it goes down to the left and up to the right. And 6 gives us up to the left and down to the right, so we know this one's actually 4. But if things were a little bit closer and we wanted to get a bit better view of what was actually happening, what we should do is we should match the window, match the graph, the size of the graph that we're comparing to this graph here. So if you look on page 388, I'll just move it into the screen here. Oh, I wish I could do this better. If you look at page 388 here, you'll see that the maximum and minimum values for the x-axis go from -4 to +6. And the maximum and minimum values for the y-axis go from -6 to +4. So we can actually go to our window and set those values in. So the minimum value for x was -4. The maximum value was 6. The x scale, SCL, just tells us how many of those little dash marks we're going to get on the x-axis. We'll just leave it at 1. Then our y minimum was -6. And our y maximum was 4. And x scales that, and x resolution we'll just leave at 1. Now if we go back to graph, we'll see that our graph is much closer to what we see on the actual question. So it's a little bit easier to match the graphs if you match them as far as the size of the window goes. That's really all we're going to cover today. Now we can graph them. We can do basic calculations of... The big calculations we're going to be looking at are zeros, maximums, and minimum values. Okay? Y-intercepts we can calculate. I can calculate a y-intercept here if I want to. If I go back to my graph, I see I have a y-intercept right here. I can actually calculate that very easily. When you y-intercept, your x is 0. So if I go to second function calculate, then go to 2 for... Oh, sorry, that's the wrong one. Second function calculate value. So I want to know what the value of y is when x equals 0. Now it tells me my y-intercept is -2. So I can calculate my y-intercept, I can calculate my minimum and maximum, I can calculate my values. Using those specific things, we can pretty much match any graph that we want to. You wonder which graph matches. Most of the time, all you're going to need to know is the behavior of the endpoints, whether it goes up to the left or down to the left, and that will tell you, along with the